Hello guys, welcome to today's video. Today I am going to discuss covalent bonding. So let us begin. Covalent bonding is a type of bonding that is found between two atoms by mutual sharing of electrons. Mutual sharing of electrons. That means both atoms will give electrons each. This is the basic thing that you need to know about covalent compounds. Covalent bond okay. The compound that is formed is a covalent compound and the number of electrons that are being shared is covalency. Just like electrovalency, this is covalency. Now the next thing is the covalent bonds, they are classified into single, double, triple. Signs are this. Equal to sign, that is not actually equal to sign, but we say it because it seems like that. So this is double dash, this is one dash, triple dash. Okay, so these are the three signs that we use. Now next thing is examples of these bonds. So to understand the example of these bonds, you need to first know the Lewis dot structure again. But since you already know that, I am not doing it directly. Okay, Cl bond with Cl. You already know the Lewis structures. I am not drawing it. Later on we have to draw it. Later on we have to draw it. Okay. Right now I am not drawing. Cl bond. Then you have this HF bond. Then you have this HCl bond. All are single bonds. What are under double bonds? You have OO bonds, you have COO bonds. Okay, these are all double bonds. This is CO2. Then you have a triple bond. Okay, triple bond is N, this N, triple bond N. So these are single, double, triple bonds. Here how many electrons are shared? One electron. Pair is shared and two electrons are being shared. Same here. Here how many? Two electron pairs and 4 electrons. Here how many? 3 electron pairs and 6 electrons are being shared. This is the basic covalent bonding. Okay. Now before moving to polar and non-polar, let us discuss the conditions that are needed for the formation of a covalent bond. In the ionic bond, whatever we have learned, opposite of this is here. Okay, mostly it is opposite. Electronegativity difference least, that is negligible or zero it can be. Okay, high EA has to be there, high IP has to be there. Okay, next is 4 or more electrons in the valence shell has to be there. 4 or more electrons in the valence shell has to be there, but there is an exception. I mean there are exceptions to this, that is hydrogen, beryllium, boron and ammonium. Hydrogen, beryllium, boron and ammonium. These are your exceptions for this. They do not have more than 4 electrons in the outermost shell, but they do form covalent compounds. So this is where the exception lies. Okay, so high En, high Ea, high IP, low En difference, that is can be negligible or zero. Done. Now let us go to the main topic of debate, that is polar and non-polar compounds. Polar and non-polar compounds. When can a compound be called polar? When can a compound be called non-polar? That is a question of debate. Now there is nothing to debate. It's easy. How? Polar compounds, basically, first top thing, there will be slight En difference. Hopefully you all know that En is electron negativity. En difference. So there will be slight En difference. That is very slight, because huge it will be divided, that we don't know. So slight En difference. Slight En difference. Very important part. Slight En difference. Next, due to this, the electrons are not at an equal distance between the two atoms. Okay, not equidistant. Electron shared, not equidistant. Okay, you can write this at not equal, not at a equal distance. Okay, not at a equal distance. That is also same. I have written electrons shared are not equidistant. Okay, are not equidistant. So they are not equidistant. That means what? HCl, it was supposed to be like this, like if H is sharing 1 electron, so it should have been like this. Okay, so this should have been equidistant. If distance from here is R, then distance from here should have been R, but it is not reality. Okay, this is a very short diagram, so let me just zoom it in. Okay, so let's take H is here. Here is the electron. Here is Cl. 1, 2, 3, 4, 5, 6. Okay, so this distance is R. So this distance also has to be R. Okay, theoretically this distance also has to be R, but it does not happen. Why? Due to a net negative charge that develops over here and net positive charge that develops over here. Slight. It is not very huge. That is a slight positive negative charge. So as a result, what happens is this electron pair is supposed to be here. It shifts somewhere over here. Okay, it shifts somewhere over here. That is towards chlorine. So this distance becomes, if this distance was initially R, now it is R1. So R1 will greater than R. Why? Because electron pair is shifting towards this chlorine. Okay, because electronegativity difference is more. This is polarity. Polarity. The term is not there right now, but I am just saying just polarity. So electron pairs are not at equal distance. They are shifting towards there. How to write that? You have to write like HCl, then you have to put an arrow over here. This is indicating that it is shifting towards that side. So this is same for HF also. Electron shifting towards that side. F is the most. Okay. So this is the basic thing of polar. Now another part is there, that is called a dipole molecule. I saw dipole molecule. This part given. Okay. What is a dipole molecule? A molecule that has slight positive charge and slight negative charge, that is del plus and del minus, is called dipole molecule. Okay. Where is the del minus over here? Here. Why is the del plus over here? Now why is the del minus not over here? This is your question. Why not? Due to physics apply here. Whenever there is an excess of electron indicates negative charge. Right, and deficit of electron always indicates a positive charge. Deficit of electron indicates a positive charge. So see here electron deficit, here more electrons are adding to. Sharing of electron is happening and that are being pulled. So more electrons, so excess, so negative charge is being developing over here. Okay, so this is what is a dipole molecule. A molecule that has slight positive and negative charge or has a positive and negative pole is called dipole molecule. Two poles, dipole molecule. Okay, so this is a polar compound, polar covalent compound. That means there is a slight En difference. Electrons shared are not equidistant. This is polar compounds. Now is non-polar compounds. Just the opposite of what is polar. What is that? First one, electronegativity difference is 0. Okay, this is again having a tremendous number of exceptions, but we do not have many exceptions. We have only CCl4 exception and CH4 exception. There are two exceptions that we have. Electronegativity difference is not 0 in this case. Electronegativity difference is not 0 in this case, but they are non-polar. Why? It is coming to it later, a little bit later. Okay. So En difference has to be 0. Exceptions are there. So ignoring the exceptions for now. This is electronegativity difference equal to 0, and electrons shared are equidistant. Electrons shared are equidistant. These are the two things that is needed for non-polar molecule. So this is how you frame the definition of a non-polar molecule. Okay. Now the thing that comes is how to know which one is polar and which one is non-polar. For that case, you have to first see the structure. If the structure is non-symmetrical, then it is a polar compound. Now this symmetry you will be learning more in class 11, not there in syllabus right now. Okay, so I am not expanding about it. Let us come directly to CCl4. We have it in your syllabus also, the Lewis dot structure. So how to draw? C in between, 4 Cl surrounding it. Let us take here Cl, here Cl, here Cl. So let us take here, let us take here, let us take here, let us take here. Done? Shading done? Now this is a non-polar because this attains a symmetry. Okay, this attains a symmetry. This is just perfect symmetry. This is just symmetry. So it attains a symmetry due to which this side dipole moment and this side dipole moment cancels out each other. This side dipole moment, this side dipole moment cancels out each other. As a result, leaving nothing. Net dipole moment gets to 0 for reason we say that it is a non-polar compound, net dipole. Okay, net dipole. This is not refractive index, this is dipole moment symbol. So do not get confused. Dipole moment net equals to 0. So that is why we will say this as a non-polar compound. Now you cannot write this definitely in your answer. What will you write? You will write molecule is symmetrical. You will write molecule is symmetrical, or you can write that net polarity is 0, okay, or net dipole moment is 0, but that is not a point because you do not know what is dipole moment right now. So the thing is molecule is symmetrical. The main thing that you need to write is molecule is symmetrical. This is symmetrical molecule. Same goes for CH4. Here there will be, instead of Cl, here there will be 4H, that is CH4. Okay, symmetrical, symmetry is remaining same. So in case of CH4 also same logic will apply. Component here, component here, component here, component here will cut out each other. So as a result, net dipole moment will get to 0. Molecule becomes symmetrical. Okay, so this is basically CCl4 and CH4 non-polar. Though electronegativity difference is not 0, but this is non-polar. Okay. Now, water. Suppose let us take the example of water. Water is oxygen here, hydrogen here. Okay. Now, why is water a polar compound? Check. Water does not form any symmetry. It's like this, something like this. This is not a symmetry. What is the symmetry? Until you join this, then it becomes some triangle. But this is not just symmetry. This is not a regular symmetry. Okay. This is something like this. Okay. The structure we use the term is bent structure. Okay. So as a result, this side will go like this side will go like this. It cannot cancel out each other. Okay. So as a result, there will be net dipole moment, something will be there. So it is a polar compound. Now in your book there is given is your Lewis dot structures of covalent compounds. That is very easy. So let me just show a few. Okay, not all I am not showing. So Cl bonding with Cl. So let us take this Cl like this, it will be bonding. Okay, Cl simple. Then is if you take nitrogen, then let's take nitrogen, it's a nitrogen. Now if you see that nitrogen, you can write like this, or you can just write like this also. Okay, this is also, this looks very weird, but it's okay. Okay, so you have got how many? 5 electrons outside. So here 2 will remain. Here you have got how many? 1 2 3 4 5 6. 1 2 3 4 5 6. Okay, so you have to show the outermost shell all electrons, so do not forget to show all that. So this is 2 and 6 8 done. Okay, so here also 2 2. So this is nitrogen. These are molecules. Okay, homogeneous molecules. Okay, next is the compounds. So compounds also there is nothing very difficult. So HF if you take, it is 1 2 3 4 5 6. Clear? So 5 6 shedding is going on. So 8 electrons total. This is the structure of an HF. CCl4 I have already shown. CH4 also I have already shown. So I am not showing that. Water. Water is basically, how will it look? Water has a bent structure. So it is like this. Now instead of this, we will just need to write. Just take this closer. So like this and like this. Okay. Okay. 1 2 3 4. So how many more? 1 2 3 4 5 6. Done. Okay. This is basically your covalent, few covalent structures. Okay. Then ammonia is there. Ammonia is very easy again. Ammonia will be nitrogen and 3 hydrogen on either sides. Okay. So this is all about covalent bonds. Now the characteristics of covalent bond. In the ionic bond, if you remember, the characteristics were good conductive electricity, rate of reaction is very fast, soluble in water, insoluble in organic solvents. All the things are reversed over here. All the things are reversed over here. Here there are no ions present. That is why they undergo ionization. What is ionization? Ions that are not previously present, but they are building up ions. That is ionization. So they undergo ionization, which is not very fast reaction. Okay. Because they do not have free ions, right? They undergo ionic reaction. Electrovalent compound, they do not have ions, so they do not undergo ionic reactions. Then they are soluble in organic solvents. They are non-polar, so they will be soluble in organic solvent. But water is being a polar, they are not going to be dissolving in water. Okay. Then they are poor conductors of electricity. Why? Again the same reason, no free ions are present. Then what else you have, you can check from the table that is given in your book on page number, let me check the page number 30. There is a table given in your book. You will see solubility, then you have is ionization, then you have is electricity conducting, boiling point, melting point, nature. So these are all the things that you can read from your book. I have told about few of the points, not all. So rest you can check from the book and you can read. So this is all that you need to know in covalent compounds in a very brief way. Now for details you definitely have to read the book, but I have explained in the short way, okay, brief way. So that was all from covalent bond. In the next video we will be discussing about coordinate bond. So see you all in the next video. Till then, stay safe.